In this question from the chapter Metals and Nonmetals, class 10th, we are given a table, and the table shows the reaction of few elements with the acids as well as with base to evolve hydrogen gas. So when you look into the table, you'll see that in case of A reacts with acid as well as base, but in this case, hydrogen gas is not produced. In case of the element B, it reacts both with acid as well as base to produce hydrogen gas. In C, hydrogen gas is produced in acid but not in base. And in case of the metal D, you can see hydrogen gas is produced in both in case of acid as well as base. Now we have to look for the amphoteric oxides. Now, what you should know that amphoteric oxides are those metal oxides which react both with acid as well as base to give salt and hydrogen gas. So there are a few examples you can take. That is, zinc oxide is one such metal, and then there is an aluminum oxide, that is Al2O3. These will react both with acid as well as base to give salt and water. So I think I should show you what the reaction. Zinc oxide react with, say, hydrochloric acid to produce salt. The salt here is ZnCl2, and the hydrogen gas is released. Zinc oxide will also react with base, that is sodium hydroxide. Say, for example, then we'll give sodium zincate, that is Na2ZnO2. That's a sodium zincate plus hydrogen gas. Now, as you can see that here, zinc oxide react both with acid as well as base to give salt and hydrogen gas. Therefore, we say zinc oxide is an amphoteric oxide. We have one more examples like aluminum oxide. If I take aluminum oxide is Al2O3, I can write above, there is a space. So aluminum oxide is what? Al2O3, that is Al2O3. This too also will say, I took the example as HCl as an acid. It reacts with HCl to produce salt and hydrogen gas. Clearly, AlCl3 is aluminum chloride, and the hydrogen gas is produced. Now let's check what happens when this aluminum oxide, this time I react with a base sodium hydroxide. It also gives sodium aluminate, that is NaAlO2. This is sodium aluminate plus hydrogen gas. So what you can observe that hydrogen gas is produced when it reacts both with acid as well as base, right? And so is case of the zinc oxide. So we can see these are two such metallic oxides which are amphoteric in nature. Let me once again tell you what are amphoteric oxide. These are those metallic oxide which react both with acid as well as with base to give salt and hydrogen gas. The next question says that which of the following is correct electronic configurations of sodium oxide? Well, sodium oxide is Na2O. It's an ionic compound. Let me show you how this ionic compound is formed. Sodium, whose configuration is 281, loses one electron to form Na plus, and one electron is lost. Why Na plus? As you can see, it loses one electron. So it has one more proton than the number of electrons. Now, if I talk about oxygen configuration is 2,6. So it gains two electrons to form O2 minus, and the configuration is 2,8. Now, this is what? It gains two electrons. This is what? Yeah. Now, if I have to show the formation of an, I should write Na with a plus over it, right? And oxygen O, and O2 minus. Now, what you can see here that sodium has one electrons in the outermost shell, and chlorine has 1, 2, 3, 4, 5, 6 electrons in the outermost shell. So therefore, two sodium atom will come and they will transfer the electrons. That means sodium will transfer one electrons from here. Another sodium atom should come. So generally this should be written like this. Let me make space below, and then I should show you the working. Now, therefore, the correct, the way the textbook has done is that we have to write Na plus and O2 minus, and showing that cross, 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 and dot, dot for the electrons being taken. And since there are two sodium, you should write 2. Now, this is what the textbook has done. Now, if you compare with this is definitely not correct as there is only one sodium. This is a type of sharing of electrons. So there is no sharing of electrons takes place. As you know, it's a formation of an ionic compound. Well, the closest one is this because you can see there are two sodium atom with 1 unit of positive charge and oxygen being 2 units of negative charge.